My dear students, in today's video I will teach you how to solve block diagram problem using signal flow graph or using Mason's gain formula. So this is the problem. Find the transfer function of the following system using Mason's gain formula. It means first we have to convert this to signal flow graph, then using the Mason's gain formula we can find out the transfer function of the system. Clear? So let us start the that is the conversion process, that is block diagram to signal flow graph. So this is very simple. That is, first let us take, this is one node, this is another node, that is x1, x2, x3, x4, x5, x6, x7, and this is C. So now denote here 7 nodes, that is we'll start from R. This is x1, x2, x3, x4, x5, x6, x7, and this is the C. Therefore, we have denoted the x1, x2, x3, x4, x5, x6, x7. So this is node R. Sorry. So let us now denote the gain of each branches. Therefore, in between R and x1, the gain is 1. x1, x2 gain is 1. x2, x3, that is G1, and x3, x4, that is also 1. x4, x5, this is gain is G2. x5, x6, G3, and x6, x7, the gain is 1, and this is also 1. Because here R to this nothing is there, therefore the gain is 1. x1 to x2 also there is nothing, no block here, therefore the gain is 1. Here G1, G2, G3, so here G1, G2, G3. So now let us connect the feedback loops. So this is the feedback, that is x1 to x7. It starts from x1 and terminates at x7. So let us do this, that is x1 to x7. Then here nothing is there, therefore the negative sign, therefore this is 1. So negative sign means this is minus 1. So here minus 1 is there. So this is x2 to x5, that is minus h1. x2 to x5 minus h1. Clear? So x3 to x7 minus h2. So this is minus here h2, therefore minus h2. So x4 to x7, x4 to x7. Okay, so minus h2, minus h2. So the feedback path is over. Now let us find the forward path. This is the forward path, that is x4 to x6. So x4 to x6, this is the forward path, that is G4. So now the conversion of block diagram to signal flow graph is over. This is very simple. Now let us find the Let us find the transfer function. So using Mason's gain formula. So first we have to find out what are the number of forward paths. That is forward paths. So forward path 1, that is obviously it will be started from input node, ends at the output node and in the same direction, and no node traverse more than once. That is, we can cross more than once in a single node. So therefore R x1, x2, x3, x4, x5, x6, x7, C. So this is one forward path because all are the directions are same and no node is crossing more than once. Therefore R x1, x2, x3, x4, x5, x6, x7, C. So here the gain is just multiplication of all the gains, that is individual branch gains. Here the branch gain is 1, here 1 is G1, G2, G3. Therefore by multiplying all, that will be G1, G2, G3 and delta 1. Delta 1 nothing but the gain of the loop which is not touching to this forward path. I think there is no loops which not touching to this forward path. So because all the loops are touching to this forward path, therefore delta 1 is equal to 1. Similarly, we can find another forward path R x1, x2, x3, x4 and x6. This is another forward path. This is not the forward path because the direction is opposite. We cannot, because already I told that the signal can flow only in one direction. The signal cannot flow in two directions or bi-direction. Therefore, we can move in this branch only. Therefore, R x1, x2, x3, x4, x6, that is x5, x7, C. The gain is P2 is equal to G1, G4, only G1, G4, that is multiplication of all branches gains. Then the delta 2 is also 1 because there is no loops which is not touching to this forward path. All the loops are touching to this forward path. Therefore, the delta 2 is also 1. So now let us find the single loops and its gains. So this is the first loop. Very simple, this is first loop. That means it starts from the path which starts from one node and terminates at the same node, that is called loop. Therefore, let us consider this node x1. Here this path is started x2, x3, x4, x5, x6, x7. Again it comes to the same node in the same direction. No changes of direction. And no nodes are traversed more than once. Therefore, this is x1, x2, x3, x4, x5, x6, x7, that is x1. So, what is the gain of this? That is, gain is G1, G2, G3 and minus 1. It means minus G1, G2, G3. Clear? Minus G1, G2, G3. Minus G1, G2, G3. So next loop we can find out. Let us assume that x2, x3, x4, x5, x2. So very simple. This starts from node 2 and x3, x4, x5 again reaches the same node. That is in the same direction. No nodes traverse more or crosses more than once. Therefore gain is G2 and minus H1. So minus G2 minus G2, so it will be x2, sorry, G1 G2 minus G1 minus G1 G2 minus G1 G2 and H1. So another loop we can find out. This is the another loop. This is another loop, that is x4, x5, x4, x5, x4, x5, x6, x7 and x4. The gain is, that is G2, G3 and minus H2, minus G2, G3, H2. So now we can find out some more loops. Is it possible? Yes, there is some more loops are possible. So 1, 2, 3, this is loop number 3. So loop number 4, that is, we can find out this x1, that is x1, x2, x3, x4, x5, x6, sorry, x4. Then we can move like this, x6, x6, then x7, x7, then again we will come to x1, x1. Then what is the gain of this? That is G1, G2, sorry, G1, G4 and minus, that is minus G1 and G4. So I think we can find out some other loops. Is it possible? So this is some other loops. Yeah, this is another loop we can find out. This x4, x6, x7 and x4, x4, x6, x4, x6, x7 and x4. Very interesting. So this is the gain is G4 minus G4H2 minus G4H2. Yeah. So now we can search for more number of loops. Is there any loops we can find out? So let us see. We can find out here x2, x3, x4 and you will move like this. So x6, then again x7, then we will come to like this, then we will move to this. It means it will start x2, x3, x4 and it will move like this, then x7, then will move like this, x5, then x2. Is it possible? But this node is touches two times, that is traverse two times. Therefore, this loop is not possible. This loop is not at all possible. So now the problem is over. Then we have to search for two non-touching loops. I think there is no two non-touching loops. Only all are single loops. And there is no three non-touching loops. Therefore, the problem is over. It is very simple. So now we can apply the Mason's gain formula. So transfer function T of S is equal to C by R, which is equal to sigma K is equal to 1 to 2, because here two number of forward path. So that is P2 delta 2 by delta, which is equal to P1 delta 1 plus P2 delta 2 divided by delta. So now C by R is equal to, what is P1 delta 1 G1 G2 G3 plus P2 G1 G4. So that is 1 minus gain product of all single loops minus G2 G3 H2 minus G1 G2 H1 minus G1 G2 G3 minus G4 H2 minus G1 G4. So this is the right answer. Thank you very much for watching this video.